Theory of Machine Laboratory Experiment Study Materials for 4th Semester Mechanical Engineering. List of experiments. 1. Study of simple link/machine/mechanisms. 2. Study of kinematic pairs. Higher pairs and lower pairs. 3. Power transmission. A. Point contact. B. Surface contact. C. Line contact. Open belt drive and cross belt drive. 4. Study of cam and follower. Forced closed/self-closed. 5. Study of crank and slotted bar mechanism. Shaper machine. 6. Study of universal governor system. Experiment No-01 AIM, study of simple link/machine/mechanisms. Objectives: to study the various terms like simple link, models, and mechanism used in theory of machine. Simple links: a link is defined as a single part which can be a resistant body or a combination of resistant bodies having inflexible connections and having a relative motion with respect to other parts of the machine. A link is also known as kinematic link or element. Links should not be confused with the parts of the mechanism. A mechanical linkage is an assembly of systems connected to manage forces and movement. The movement of a body, or link, is studied using geometry, so the link is considered to be rigid. The connections between links are modeled as providing ideal movement, pure rotation, or sliding. Machines are the combination of simple links and mechanisms. When a mechanism is required to transmit power or to do some particular type of work, it then becomes a machine. Lathe machine, shaper machine, car etc. are the example of machine. In such case, various links have to be designed to withstand the static and dynamic force safely. Or a machine is a combination of resistant bodies, links or elements, with successfully constrained relative motions, which is used for transmitting other forms of energy into mechanical energy or transmitting and modifying available energy to do some particular kind of work. Mechanisms: according to the definition, both forces and motions are transmitted and modified in a machine. The way in which the parts of a machine are interconnected and guided to produce a required output motion from a given input motion is known as the mechanism of the machine. There are 6 different types of mechanism actuators: cams, gears, levers, ratchets, springs. A good example of a mechanism is a seesaw. In a seesaw, motion is transferred evenly across, providing there are equal amounts of force at each end. Questions: 1. Differentiate between links, machine, and mechanisms. 2. Describe in details about 6 types of mechanism used in general practice. AIM, study of kinematic pairs. Experiment No-02 Objectives, detailed study of kinematic pairs through working model. Theory: when 2 links or elements which have completely or successfully constrained relative motion between them, then it constitute a kinematic pair. Kinematic pair may be classified on the basis of types of constraints and the relative motion between their links. 1. Classification based on types of contact: A. Lower pair. B. Higher pair. Lower pair: when 2 links of a pair have a surface contact between them while transmitting motion such that the surface on one sides over the other surface, then the pair is called lower pair. Higher pair: when 2 links of a pair having line or a point contact between them, and accomplish partly sliding and partly turning relative motion between them, then the pair is so formed is called higher pair. 2. Classification based on types of constraint: A. Closed pair. B. Unclosed pair. Closed pair: when the link of a kinematic pair is held together mechanically, then the pair is called closed pair. Unclosed pair: when the link of a kinematic pair are not held together mechanically, then the pair is so formed is called unclosed pair. 3. Classification based on relative motion: A. Sliding pair. B. Rolling pair. C. Turning pair. D. Screw pair. E. Spherical pair. A. Sliding pair: when the link of a kinematic pair have a sliding motion relative to each other, then they form sliding pair. B. Rolling pair: when the link of a kinematic pair have a rolling motion relative to each other, then they form rolling pair. C. Turning pair, when the link of a kinematic pair have a turning motion relative to each other then they form turning pair. D. Screw pair, when the link of a kinematic pair have turning as well as a sliding motion relative to each other then they form screw pair. E. Spherical pair, when the link of a kinematic pair in the form of a sphere turns inside the other fixed link, then they form spherical pair. For classification based on types of contact: A. Point contact. B. Surface contact. C. Line contact. For example, open belt drive and close belt drive. Questions: 1. Define kinematic pairs. 2. What are the difference between point contact, surface contact, and line contact? Experiment No-3 Title: Power Transmission, Objectives, Detailed Study of Kinematic Pairs for Power Transmission in Open Belt Drive and Close Belt Drive and to find the length of belts. Theory: the transmission of power is mainly accomplished with higher pair. The kinematic pair in which there is a line or a point contact between two kinematic links. Power transmission can be classified as follows. A. Flexible drive. 1 belt drive. 2. Rope drive. 3. Chain drive. B. Contact drive, 1 cam and follower drive. C. Mesh drive, 1 gear drive. 2 screw and nut drive. Flat and V-belt drive, power is transmitted from one shaft to another by means of belt. Both the shafts are provided with pulleys accommodate the belt on their outer surface. The friction between the belt and the pulleys enable the power to transmit from the driving shaft to the driven shaft. While transmitting power the belt remain under tension. Types of flat belt drive: 1 open belt drive. 2 close belt drive. Open belt drive: in this type of drive, both the pulleys i.e. driver pulley and driven pulley rotate in same direction and they are rearranged in parallel. When the distance between the pulley are large, the tight side of the belt should be kept lower side to increase the contact of belt on the pulley. This is done to avoid the chances of slipping of the belt over the pulley. Cross belt drive: in this case, both the pulley i.e. driver pulley and driven pulley rotates in the opposite direction as shown in Fig. Angle of contact of belt on both the pulleys are equal. There is more wear and tear in this system than open belt drive. There are another 3 types of belt drive. 1. Belt drive with an idler jockey pulley. 2 intermediate pulleys. 3 fast and loose pulley drive. Length of belt for open belt drive. Observation for open belt drive: diameter of smaller pulley equals diameter of larger pulley equals distance between the center of 2 pulleys equals angle of lap equals table for open belt drive. Number of observation: length of belt, mean length of belt. Length of belt for cross belt drive. Observation for cross belt drive: diameter of smaller pulley equals diameter of larger pulley equals distance between the center of 2 pulleys equals angle of lap equals table for cross belt drive. Number of observation: length of belt, mean length of belt. Questions: 1. Differentiate between open belt drive and cross belt drive. 2. Classify various types of power transmission. Experiment No-04 Title: Study of cam and follower. Forced closed and self-closed. Objectives: to study the terminology and various types of pair formed by cam and followers mechanism. Theory: a cam may be defined as a rotating elements which produce a rotating, reciprocating, or oscillating motion to the other element attached to it, called follower. The terminologies are as follows. Cam profile: the surface of cam which comes in contact with that of follower is called cam profile. Base circle: the smallest circle, drawn from the center of rotation of cam forming the part of cam profile, is called base circle. Trace point: it is a reference point on the follower to make pitch curve. In case of knife edge follower, it is located at the knife edge itself, and in case of roller follower, it is located at the roller center. Pitch curve: it is the path of trace point assuming that the cam is fixed and the follower moves around it. Prime circle: it is the smallest circle drawn to the pitch curve from the center of rotation of the cam. Pressure angle: it is the angle between the normal to the pitch curve and the line of motion of the follower. This angel is very important for the design of the cam. Lift or follower, it is the maximum distance of the follower from the base circle of the cam. It is also called the stroke of the follower. Pitch point, it is the point on the pitch curve where the pressure angle is maximum. Angle of ascent, the angle of rotation of cam from the position when the follower begins to rise till it reaches its highest position is called angle of ascent. Angle of dwell, it is the angle through which the cam turns while the follower remains stationary at the highest or lowest point. Angle of descent, it is the angle through which the cam turns during the time the follower returns to its initial position. Angle of action of cam can be defined as the angle moved by the cam from beginning of ascent to the termination of descent. Classification of cam can be classified as follows. 1 disc or plate cam. 2 cylindrical cam. 3 translating cam. 4 wedge cam. 5 spiral cam. 6 hearted shaped cam. Follower. A follower is a rotating or oscillating element that follows the motion of cam by direct contact. It converts rotary motion of cam into reciprocating or oscillating motion. It can be classified as follows. 1 knife edge follower. 2 roller follower. 3 flat-faced follower. 4 spherical follower. 5 radial follower. 6 offset follower. Homework. Study and observe all types of cam and followers available at workshop and make a brief note. Questions. 1. Define the terminology and various types of pair formed by cam and followers mechanisms. Experiment No-05 Title, Study of Crank and Slotted Bar Mechanism. Shaper Machine. Objectives, to study the quick return motion mechanism. Theory. A quick return mechanism in an apparatus that converts circular motion into reciprocating motion in presses and shaping machines, which are utilized to shape stocks of metal into flat surfaces. This mechanism is mostly used in shaping machines, slotting machines, and in rotary internal combustion engines. Shaper machine. A shaper machine is a machine tool that uses linear relative motion between the work pieces and a single point cutting tool. It is used for removing material from a work pieces to produce a flat surface on the work pieces. Various parts of a shaper machine. Base. This is the strongest part of a machine that has the ability to absorb the vibration produced during machining. Cast iron is a suitable material to absorb all the various induced during various types of operation. Ram. Ram carries the single point cutting tool, hold and reciprocates on the column guideways. Work table. This is generally used to hold the machine vise where the work piece will be held properly for various types of operation. Column. It is a box-like structure which is mounted on the base inside the column, a driving mechanism. Clapper box. Clapper box holds the tool firmly during its cutting stroke and idle stroke. Types of shaper machine. 1 crank type, mechanisms involved with quick return motion mechanism. 2 clapper box with rocker arm. 3 ratchet and pawl mechanism. Working principle of shaper machine. Shaping is the operation of removing a layer of material from the flat surface of the work pieces using a reciprocating single point cutting tool. In shaping machine, the forward stroke of a tool will be considered as the cutting stroke in which material removal is taking place from the work pieces, and return stroke will be taking as an idle stroke just to move backward to its original position. Observations. Draw a figure of shaper machine and take the reading of all necessary dimensions. Questions. 1. What do you mean by quick return motion mechanism? Describe in details. 2. Define what are the operation can be performed in shaper machine. Experiment No-06 Title, Study of Universal Governor System. Objectives, to study the function of governors. Theory. The function of a governor is to maintain the speed of an engine within specified limit, whenever there is a variation of load. Principle of governor operation. When the load on an engine increases or decreases, governor speed decreases or increases respectively to the extent of load variation. This variation of speed is controlled by the governor within prescribed narrow limits of mean speed. This necessitates that, when the load increases and consequently decreasing the speed, the fuel supply to the engine has to be increased accordingly to compensate for the loss of speed, so that it brings the speed back to the mean speed. Conversely, when the load decreases, thus increasing the speed, the fuel supply has to be reduced.